Alright, hello everyone. Let's get going here with our first remote access video here. Basically this one we're starting is chapter 4, and we're going to start off by talking about angles and how we measure those angles. And basically an angle, don't need that, is formed by rotating a ray, which is essentially basically an arrow, about its endpoint. That's going to be the end opposite of the, like where the arrowhead would be of that. And the endpoint is called the vertex of the angle. One of the things that happens when you get really into math or physics is you learn a lot of the Greek alphabet. You don't really learn how to write words in Greek, but you sure learn to identify a lot of the letters. For example, this is alpha, this is beta, this is gamma, and this is theta. So those four you probably want to be pretty certain you can recognize. A lot of times you'll see alpha written kind of like that. Beta, it's like a B but with that longer leg on it. Gamma is almost like an alpha but a little skinnier and pointed kind of upwards. That didn't go very well, but kind of like that. A lot of times people write it. And then of course theta, just that it's an O with a little line through the middle. So note that because these angles are made with rotations, you can actually rotate in either direction. Convention says that we can have positive rotations, and that we call those positive rotations, those are the rotations that go counter clockwise. So the opposite direction that the hands on a clock turn. So, and that's often written CCW. Or you can have negative rotations, which are going to be clockwise. And again, that sometimes is just written CW. What we have here is just some examples. You can see down here at the bottom, the vertex, the end point right there, rotating about it is right there. That's where we're going to rotate it about. It's like our pivot point. The initial side is basically where we started before we did any of the rotations. So that's your initial side right there in that blue. Then you end up over here by rotating along that little light pink curved arrow. You rotate some angle, we're calling that theta, over to the terminal side here, which is there in red like that. And then that is the terminal position of the ray, and so therefore the theta between them is that angle, is how much we did end up rotating it. And you can see this is a positive rotation because we started on the initial side and we went the opposite direction of how a clock hand turns, so counterclockwise. On this second one, you can see we're starting on the initial side over here to the left, and we're rotating the same direction that clock hands turn, and that's a negative rotation. All right, and then one last big thing here you can have is, on this last example, is you can have two different angles that actually still end up having you terminate or have your ray, your terminal side of your ray, be in the same position. They're called coterminal. If you look this side from the initial, this angle alpha is just a rotation like that. But for beta, we're actually rotating around this way, multiple times in the negative direction, and still, though, ending up in the same position as the rotation for alpha. So those are called coterminal. All right. Next thing is standard position. So we all have to start agreeing on where we're going to measure this, all of our angles from. And so if we have an angle that's in a Cartesian coordinate system, we can have our standard position basically be the x-axis pointed right along it. And if we do that, then we can all agree that once we give an angle, we can all just kind of look at that same spot and say, all right, let's all go there. Because otherwise what would happen is I might say, well, the angle was such and such. The angle was 12. We haven't really talked about how we measure, but I guess y'all know degrees. So the angle is 12 degrees. Well, that's great. Did I measure it 12? Was this my initial side and then this was 12 degrees? Or was this my initial side and then this was 12 degrees? Like what was the 12-degree rotation? What was it from? And so that's why we need to have this sort of convention where we can all agree on where we're going to measure it from. So in standard position, it's going to be in standard position if its vertex is at the origin. Think the point 0, 0. Okay? That wasn't a very good 0. And its initial side lies on the positive x-axis. So we're measuring it from that positive x-axis. It's pointed along that. So if we look here, this is the initial side here. You can see it there in blue. This is the initial side, okay? And then over here again, we have a terminal side. Now this is a negative rotation in this picture, but then there's the terminal side, but we measured it from that positive x-axis. All right, just like in the pictures above. And again, here you can see we've got an initial side here in blue and a terminal side here in red. This one is a positive angle and takes us on around to our terminal side. Okay? And after that, we think that one of the main things we're going to do is we need to figure out, well, what are we going to measure these in? First one that most people already know at this point, and I just mentioned a minute ago, is degrees. So you can measure these things in degrees, or you can measure them in radians. Hopefully, by the end of this, you will start to prefer radians, as they tend to be quite a bit more simplified, I guess, than degrees, less kind of arbitrary. There's actually kind of a reason for them. So a measure of 1 degree is assigned to an angle resulting from a rotation of 1/360th of a complete revolution counterclockwise about the vertex. So essentially, if we looked at this and we said, all right, here we are starting, here is our initial side along the x-axis, and we are going to rotate all the way around, one complete rotation, so that our terminal side is right along the x-axis as well, and we end up right where we started. If we did that, and we looked at how much we turned, and we took 1/360th of that, one tiny little division, we divided it up into 360 equal little divisions all the way along, all the way around. It's going to be a lot more than the number of little tick marks I'm drawing, but you divide it up equally, 360 parts all the way around, grab one of those, and we count that as 1 degree. All right, so let's take a look at some examples. Here we have acute angles. Those are going to be less than 90. We have right angles. Those that are right at 90 degrees when we've basically done 1/4 of the full 360-degree rotation. An obtuse angle is greater than 90. Straight angle at 180 degrees. That's basically just going to end up giving us a straight line with where we started with. Here's some other just little angles. This is a positive 540. This is a minus 300. Here's a 675 where we're going around, one full rotation here and then continuing on for another almost full rotation. And it's kind of like this one. We did one full rotation there before doing another half of rotation there. And so that gets us to that 540. We can also kind of break this up, and we can define 1 minute, right? One with one little like a apostrophe there is defined as 1/60th of a degree. And then 1 second is defined as 1/3600th of a degree, which, is also going to be 1/60th of 1 minute. Okay, so just like minutes and seconds as far as time goes, a minute is a 60th of an hour, and a second is a 60th of a minute. Okay, we don't really need to mess with that. We did some important angles up above already. So let's take a look at just some examples of just drawing some of these angles, and then that'll be it for this video. And so first off, this is 60 degrees. So we start off by finding our x-axis here. This is our our standard position. That's where we're starting from, and then we're going to rotate to 60 degrees. I'm not going to do this exactly, but it's going to be somewhere right about there. I'm not breaking out a protractor or anything like that to do this on my little screen here, but then that'd be 60 degrees right there. The next one we have is 135. So again, we have this x-axis where we want to look initially, and then we're going to go all the way around to 135 degrees, which is going to be right there. And look like that. That's the 135 degrees. Next we have -240. Okay, so again, we're starting with that positive x-axis, and we're going to rotate around in the negative direction to 240, which is going to be something like that. And the -240 is this way. All right, -240 degrees that way. And so you can kind of see how you do this. And if you had yourself a protractor, you could measure these more precisely than I am doing at the moment, but you get the kind of basic idea. So I'm going to leave the last few here for you to try. I'll go ahead and probably complete them for the notes for you online, so if you want to take a look at when they back up and see if you got them right. So that's it for this